Hi everyone, welcome to day 11 of Just Enough Python for AI. Today we will wind up pandas. So till now in day 9 and day 10 videos we have seen quite a bit of pandas. Today we will look at summarizing and grouping of data. We will know how to summarize your dataset using techniques like .describe and .value counts. We will also look at how we can group rows by specific categories using .groupby and extract meaningful insights. And we can perform some aggregations, transformations, and filtering on group data. So let's start. First, we will import pandas. Then we will read our favorite data set, which is the Titanic data set. We have been using this data set for quite some time now. This is how it looks like, very familiar. Now, we can get a summary overview of this data, all the columns, by doing .info, df.info. Next, we will look at the .describe method that pandas gives us. It gives us a statistical overview of all the numerical columns. Let's just execute this code and you will see that we get a very nice statistical overview of each of these columns. So we get the count, then we get a mean for each column. We get standard deviation for each column. I'm not going to explain what is standard deviation in this video, but it's a statistical method. Just understand that. Then you get the minimum value for each of these columns. Then we have some percentile values, 25 percentile, 50 percentile, and 75 percentile for each of the rows. Each of the columns. I have a small interesting exercise for you. If you explore the age column in the data frame itself, you would notice that none of the passengers had an age of 20.125. Yet, the 25 percentile for the age column is coming out to be 20.125. I would like you to find why. It is correct value. It's not like the value is wrong. If it starts giving out wrong values, nobody will trust it. So obviously it is the right value. But I want you to figure out how does df.describe comes to this value for 25 percentile for the age column. If you find this, do put that in the comment box. I'll be very interested to know who all are able to find this on their own. And I have no problems if you are using ChatGPT or any other language model to understand how we have arrived at 20.125 for 25 percentile for the age column. Next, we will look at grouping of data. So sometimes, in fact, quite often, many a times, you will need to calculate aggregated metrics like mean, average, sum, count, grouped by certain categories. That's when we use the .groupby method to group the data by column values. Let's see some examples. Let's see an example of basic grouping first. We want to explore how many passengers survived based on their genders. So from this data frame where each row is a passenger, we want to figure out how many survived by gender, as in how many males survived and how many females survived. For that, we'll have to first group by gender, which is here, the column sex. So we are doing df.groupby. Groupby is the method that we are using. Then we are passing the column on which we are doing group by, which is here, the sex column. And then we are saying do a mean, do an average of the survived columns. So survived is the column that tells you whether that person survived or not. The value of 0 means the person did not survive, while the value of 1 means the person actually survived. So let's first execute this code and see. So what it shows us that for females, the survival rate was 74.2038, almost 74%. For males, the survival rate was only 18.89, you can say around 19%. This is the mean value for female, this is the mean value for male. This is also the percentage survival rate. If you multiply this value by 100, you'll get 74.2038. And for this, you'll get 18.89. So both mean and the percentage survival rate we are able to get here. That is because why the mean is matching the percentage survival rate is because the values are such that we have only zeros and one. So we are able to get percentage survival rate by just looking at mean. If the values were something else, we had to calculate the percentage survival rate. We can also change this to, for example, count. This will give us the count, the actual number of females on the ship, which is 314, and the actual number of males on the ship, which was 577. We can also look at, say, for example, sum. Now, when it is sum, is going to count the sum of survived. So you will actually see that out of 300 something, 233 females survived, while only 109 males survived out of 500 and something males. Let's again just change it to mean. So looking at this value, it looks like we often say that it's a man's world, but at least that ship wasn't a man's ship. It was much better to be a female on that fateful night when Titanic sank. This result is giving average survival rate for males and females. Next, look at grouping by multiple columns. So here we are grouping by both sex and passenger class. Let's first execute this for and then we'll understand. So we are saying group by sex and passenger class. Your first index is sex, your second index is passenger class, and then again we are saying how many of them survived. We are looking at the percentage of people within these classes who survived. So if you look at the survival rate, the output of this, females who were in the passenger class 1, that is the topmost class, their survival rate was 96.8085. That is almost 97%. For passenger class 2, it was 92, and for passenger class 3, it was 50. So even if you are female, it's better to be rich. The same trend is also in male. If you are in passenger class 1, your survival rate was around 36-37% and goes down to just 13% if you were in passenger class 3. So at least on that ship, on that fateful night when Titanic sank, you were lucky if you were female and you were rich. If you are poor and male, nobody gave a damn about you. So this is an example of grouping by multiple columns. Next, let's look at the aggregation function. So we do have a built-in .agg function which allows you to calculate multiple metrics for the group data. So till now, if you notice, we have been calculating each matrix at a time. We could calculate .min, we could change it to .count or .sum or .min, .max, but one at a time. If you want to have multiple metrics at a time, at a single time, you can use this .agg function. So let's see what we are doing here. We are saying again df.groupby. We are grouping by passenger class, and then we are looking at the age and fare. So we are going to have metrics for both age and fare, and which metrics? We are applying .agg function, and we are saying for each of these column, age and fare, calculate mean, max and min. Let's execute this code and see the result. Can you see how beautiful it is? For each passenger class 1, 2, 3, for each column age and fare, we are getting mean, max and min. Mean, max and min. Without this .agg function, the aggregation function, to achieve this output, you will write a decent number of lines of code. But here, all you need is one line. Some of the common aggregation tasks often applied to group data are count. Count is the actual count of rows. Mean is the average. Sum is the total sum for each group. And then custom aggregation. Sometimes we may define our own logic for aggregation. We are not covering custom aggregation in this video. We have some more examples. Count of passengers in each class. So if you see, we are grouping by passenger class and then we are counting the passenger ID column. Basically, we are counting the rows. You could put any row here instead of passenger ID. So you're getting in passenger class 1, you had 216 passengers. In passenger class 2, you had 184. And in the passenger class 3, you had 491 passengers. Then the next example is total and average fare grouped by embarkation point. So embarkation point is here. If you notice the original data frame, see the last column. So we have S, C, and I think a couple of more values. We have 3 values for embarkation point, C, Q, and S. And the actual meaning for C is Chebourg. I hope I'm pronouncing correctly. Q is for Queenstown and S is for Southampton. I believe these were the cities in UK from where the Titanic started. And there were 3 points, 3 stations, or 3 ports from where people could hop onto the ship. So we are saying find the average fare and total fare for each of these embarkation point. Let's execute this code and see. So we are seeing that for C, which is Chebourg, the sum was quite a bit of money, 10,072 for that time. I believe it's good money. And the mean was 59. Looks like this is the richest place because the mean is quite high. So probably many of them went for passenger class 1 or 2. For Queenstown, you can see both the sum and the mean are quite low. So probably very few people got onto Titanic from this city, this port. And even those who actually went on to the ship, they bought probably mostly passenger class 3, third class tickets. For Southampton, the sum is quite good, a lot of money coming in, but the mean is somewhere in the middle. So probably it had a mixture of people who could afford passenger class 1, the topmost passenger class, and people who could only afford the third class, that is the passenger class 3. Next, let's look at filtering group data. So basically, we are filtering the data after applying grouping. For example, we have find groups where the average age is greater than 30. So we are grouping by passenger class. So basically, we will first group the data frame by passenger class. So we have, I think, 3 passenger class, 1, 2, and 3. So we'll first group them by passenger class, and then we will only select the passenger class where the average age, mean is basically nothing but average, where the average age for the passengers in that passenger class is greater than 30. Let's execute this code and we see that we have some data. We need to verify if our logic actually worked or not. Let's see the number of rows in this grouped by data frame, grouped age data frame. Let's just quickly check how many rows we have. We have 216 rows. So definitely we did filter some records. Now let's see. We have 3 passenger class, 1, 2, and 3. Since we are seeing top 5, we can only see all the 5 rows are passenger class 1. Let's also see maybe the bottom 5. The bottom 5 are also all 5 from passenger class 1. So I can safely assume, since it's already grouped by passenger class, all the passengers from each class are together, and we can see the top 5 are from passenger class 1. The bottom 5 are passenger class 1. So basically all the rows, all the passengers, all these 216 passengers are from passenger class 1. We can verify it one more time. We can just simply say dot, let's say, which is the column, P class, that is passenger class dot value count. So this will give you the value count for this passenger class. So it will give you the unique values in this passenger class column. So we can see that there's only one unique value, which is 1, passenger class 1, and the number of rows are 216. We have this passenger class 1 216 times. This basically means that only the passenger class 1 is where the average age was more than 30. For every other passenger class, the average age was less than 30. This also makes sense. Very often you will see that people who can afford luxury, passenger class 1 is a luxury. People who have money, people who have reached a certain level in their life, it takes time. And often they are older people. And that's the reason you are seeing here that it's only passenger class 1 where the average age is more than 30. They are mostly older people. The last example is pivot tables. Now, pivot tables are quite useful for summarizing data by reshaping and aggregating it. It's a big topic. It's a big topic by itself. It requires probably a couple of videos by itself. So I'm not going to go into details of pivot table. I'm just going to give you an example. Let's first execute this code and see what happens. So we are saying df.pivot table. It's a built-in function, and we are passing these values where we are saying index should be 6. So we have this male and female as the index. We are transforming the data. This male and female were earlier the values in one of the columns. Now we are saying this is the index. Then the columns are passenger class. So passenger class is 1, 2, and 3. These are the columns. And we are looking at the survived column from the original data set, and we are taking a mean applied on this survived column. So we get for passenger class 1 and female, the survival rate was 96.8, almost 97. For passenger class 2, it's 92%, and for passenger class 3, 50%. And for similarly for male, it is 36.88% for passenger class 1 and goes down to 13% for passenger class 3. If you remember, we did this before. We did find the survival rate by each passenger class and by gender. If we go up somewhere here, let's see. Yeah, here. This is exactly what we have here as well. We are saying for gender female and for passenger class 1, this is the survival rate. And we also look at passenger class 2, passenger class 3, and then we do the same for male. This is exactly what we are seeing here as well. But the structure of the data, how you look at it, is different. And very often there will be a scenario where this view will make more sense than the previous view. This is an example of using pivot tables. This brings us to the end of today's session on pandas. This effectively completes our pandas topic. At the end, we have some quick exercises as we always have. I only have 3 questions here. None of them are even remotely difficult. I'm pretty sure you all will be able to get it sorted. If not, if you have any questions, any confusions, please be my guest in the comment box. Next, we'll go to day 10 exercise solutions, the questions that were asked in our previous video. The first question was explore the Titanic data set. I think we have already explored enough, but let's explore once again. I've given a link. Download the Titanic dataset from this link and then load into a pandas data frame. Let's do it quickly. Then the next question was to drop rows where age or embarked are missing. Basically, wherever we have missing values in the column age or embarked. So we'll first see if we even have missing values or not. So we have total 891 records, and we have 889 non-null values in embarked. That means there are 2 null values in embarked column, and for the age column we have 714 non-null values. Others are null values. So Let's see what we can do. So to remove the rows where age or embarked column has null values, we can use df.drop_na, and we are passing these two columns as subset. The next question was to fill in missing fare values with the average fare. Let's first check if we have any missing values in the fare column. Actually, no. We have 891 non-null values. So every row has a fare, a value for the fare column. But for the sake of it, this is what you would have done if there was a null value. We would have filled that null value with the mean of the fare. So for the fare column, we are applying the fill na method, and we are saying that fill the missing value with the mean of the fare values. But since we don't have any missing values, it will not fill anything. But this is for the sake of knowing. Now the next question is to standardize column names, that is to make them lowercase and replace spaces with underscores. If I look at my column names, I don't have any spaces, right? Yeah, there are no spaces, but I do have uppercase. But for the sake of it, we'll write the code anyway. And we are actually chaining our methods. So we are saying df.columns.string. We are converting the column names to lowercase here. And then again, we are, after converting to lowercase, we are saying replace any space with underscore. Since we don't have any space, this part of the code will not do anything. It will still execute. It will just not find any space, so it will not replace anything. And the last one, the last question is add a new column named family size, which is the sum of sibling, spouse, SBSP, and PARCH, PARCH, parent and child. This, in fact, we did in our last video itself. There was an example that did exactly same. We are adding a new column named family size, and we are just summing these two columns. Let's execute all of them together and see what we get. So the first question was to drop rows where age or embarked are missing. We will check if we have dropped any rows or not just now using .info. Let's just check now. So as you can see, for both age and where is that, embarked, we have 712 non-null values. That is also equal to the actual number of passengers. Others have been dropped. Don't get confused by looking at this 0 to 890. 0 to 890 is the index, but the actual number of entries are now 712 because we did drop entries in between. So if you look at this data set, this data frame, and expand it, you will see that you will have some missing indexes in between. But eventually you will have 712 rows. The number of index will go from 0 to 899 with some missing here and there who have been dropped. The next question was to impute the missing value for fare. Since we did not have any missing value, nothing would have been imputed, nothing would have been replaced, but this is our fare column. Then was to standardize column names. Since we did not had any spaces, we don't have any underscores in the names, but we have changed the column names to all lowercase. And then we did add a new column named family size, which is the sum of the other two columns, which is SIB-SP and PARCH. And then the last question, I believe, third question. Third question was to sort and filter, sort passengers by fare in descending order, which is this. As you can see, we have sorted passengers by fare in descending order. So here is your fare, and you can see the passengers who paid the highest fare are on the top. And then we descend as we go down. Then what is the next question? The next question is filter and print all passengers who paid more than 100 and were older than 30. So we are basically applying two conditions here. First is that fare should be greater than 100 and age should be greater than 30. Let's execute this code. You will see this, all these passengers, their age is over 30 and the fare is over 100. Then the last question, I believe this is the last question, question number 4, is to identify duplicate. Check if dataset has duplicates and remove them if any. So first we need to check if our dataset has any duplicates or not. We are going to use the dot duplicated method, and we are passing all those rows which were duplicates into a new data frame. And then we will see the length. We're actually counting the number of rows in our new data frame named duplicate rows. Let's execute this code, and we see the number of rows in this duplicate rows data frame is 0. That means we don't have any duplicate values, duplicate rows in our data frame, so there is nothing to remove. This brings us to the end of today's video. We are now effectively winding up Pandas. In the last 3 days, we have learned a lot. We have learned a lot about Pandas and what Pandas can do. Pandas is very important, incredibly important. Pandas is the best friend of every data scientist. There is no data scientist out there who can live without Pandas. The only thing that is left in our journey is now visualization. So we will be using two libraries, matplotlib and seaborn, to visualize our data, which will be our day 12 and day 13. I hope you have liked and enjoyed this journey till now. I will see you in the next one.